So children, our last chapter is visualizing solid shapes. In this only, we will see some theory portion. The before the videos, it will be much understood. And see this chapter, what we are going to learn is regarding the 2D shapes like triangles, circles, squares, parallelograms, and then the 3D shapes like cubes, cuboids, cylinders, cones, all these things. The number of faces, vertices, edges, and then using the Euler's formula for proving, okay, Euler's theorem which is given here. So these all things are a part of this chapter. Let's learn more through the video part and of this chapter.
In this module, you will learn about different perspectives of three-dimensional shapes.
Okay, so this is the views of 3D shapes. Let's see what are the things here.
A plane shape, like rectangle, will have only two dimensions. The two dimensions are length and breadth. A solid shape, like a cuboid, will have three dimensions. These three dimensions are length, breadth, and height. Three-dimensional shapes look different from different views.
Now see, already you are knowing that while we are discussing things that we refer to many figures as plane figures. Then you also must be remembering the formula for calculating the volume of a cuboid, that is length into breadth into height. So this a brick is a shape of a cuboid only. We have a dimension called as length, then breadth, and then height. They all three are perpendicular to each other. This is how it goes.
For example, if we view the cuboid from this position, the cuboid looks as shown. And if we view,
And if you remember, very frequently we are comparing a duster only with that cuboid. Okay, it is a shape of a cuboid only. Cuboid is a shape. We can have many examples of that. Okay, see what?
from a little above, it looks as shown. These views are called perspectives.
Now see what they are talking about the perspectives is. Suppose this is a cuboid, but if you are seeing from the front side, you will see that this portion, this space is a rectangle only. So accordingly, if you see it from the top, it will be also a rectangle only. So though it might be a solid shape, but seeing it from the top view, from the front view, from the side view, it may appear to be different. And it is not that it's not a solid, it is a solid, but perspective is important. You must have heard the story. Same thing can be judged or visualized by different people differently. That's how things goes.
Every solid shape will have three perspectives in which it will look exactly like a two-dimensional figure. In fact, three-dimensional solids are formed by combining
Yes. So that's what I'm saying, that three-dimensional solids are made from 2D shapes only. Like we are having rectangles in a cuboid. Let's see. This is a rectangle. The back also one rectangle. This also one rectangle. So these rectangles are plane figures, but they are made when they combine together, they form a solid shape or 3D figure.
dimensional plane figures. For the cuboid shown, the front view exactly looks like a rectangle. The side view exactly looks like a square. The top view looks like a rectangle.
These are the views I was talking about.
The three-dimensional shape cuboid in these perspectives look like a two-dimensional figure since we cannot see the third dimension.
That means
At
at
this
the
time
time,
and a different
that means At a time when we are seeing only one of the faces and not the complete solid shape. So a part of the solid shape we are seeing. See a house, they are talking about perspectives
From
also.
perspectives of a house. Now, we are standing here. The view we get from here is shown beside. We look exactly from one side of the house. This is the perspective of the side of the house. We call this side view.
Okay, this is side view. When you are viewing on the side.
Next, we will look from the front of the house. The perspective we get is the front view of the house.
So from the front view also it looks like a plane figure only. That's what it is trying to say, that a solid shape could be made up of many plane figures.
Next, we will look at the house from top. This perspective shows the top view of the house, which is the roof. Next, we will observe the perspectives of a set of cubes arranged in the manner shown.
You must have played with these blocks when you were small children, and these are also joined together. When you join together, you can form so many shapes. So perspectives, by numbering, they are showing that which face you are seeing.
First, we start with the front view. Here, we can observe that only the orange, green and purple blocks are visible. The blue block cannot be seen.
Now see, in fact, you cannot judge about the depth also. The depth of this inside the one you cannot judge when you see from the front.
Because it is lying behind the orange block. In the side view, we cannot see the blue and green
There is
blocks
only
since
this
they
blue
lie
and
behind the purple block. The top view is as follows. Here, we can see all the blocks. Now, let's see
You
what
might have also seen through Google Maps sometimes they are showing to the satellites how your house looks like. So when you are seeing your house being on the road or when you are inside it, you are having a different view. But when you see from the satellite, it looks like what? Top view only you are seeing. Might have seen many times they are showing that how the images look like when the houses or the people around or the things around are viewed from the top with the satellite.
we can conclude from these observations. Every three-dimensional shape will look like a two-dimensional shape from certain perspectives. These perspectives are front view, side view, and top view.
Okay, the perspective are different. The solid shape will look like a plane figure only.
In this module,
Here, let's see something more.
in this module, you will learn about three-dimensional shapes and the concept of nets.
So here we have sketches also. Let's see how they are drawing.
Figures such as squares, rectangles, triangles, and circles are called two-dimensional figures. These figures have only two dimensions, length and breadth. Two-dimensional figures can be combined to form three-dimensional shapes.
Just so you have learned that also. So we are taking 2D figures. If we combine them, we form a 3D shape.
For example, 6 squares can be combined to form a cube. Likewise,
Let's see about the polyhedrons. This is our main topic.
In this module, you will learn about different polyhedrons and their properties. Here are 6 congruent squares. We attach the squares to form a cube. Similarly,
We are knowing a cube has got 6 faces, and when we are combining all the 6 faces, these each individually a face is what? A square only. So from the 2D shape we can form a 3D shape. And if you are breaking that cube or a solid figure, eventually we will get plane figures or 2D shapes.
we take 4 congruent triangles and attach them to form a pyramid.
So see, 4 triangles we are taking and making a pyramid.
These solid shapes in general are called polyhedrons. This word comes from the classical Greek language. Poly means many
Okay, poly means
and
many
hedrons
faces.
means faces. A polyhedron is a solid shape made up of polygonal surfaces. The polygonal surfaces are called the faces. A cube is made up of 6 square faces.
So we are knowing a cube has got 6 faces. Accordingly, it will have so many vertices, edges. This also we have to learn.
And is called a hexahedron, where hexa
So a cube could be also called as hexahedron also.
means 6, and a triangular pyramid is made up of 4 triangular faces and is called a tetrahedron, where tetra means 4.
4. So these
Next,
words are used so many
We will
times.
learn how to analyze a polyhedron. We take a simple polyhedron, a cube. The cube has 6 flat faces.
So there are 6 faces. 1, 2, 3, 4 that side, 5 below, and at the back. In the 2D representation, we cannot show all the 6, but still this triangle will show because 3D shapes cannot be shown very properly because this is a plane figure only. By different colors.
Two faces need to form an edge.
So see, when 2 faces are combined, this yellow line is called as edge.
3 or more edges need to form a vertex.
Now, when 3 edges are meeting at one point, it is called as a vertex. So vertex, edge, these all are terms common to all the polyhedrons, and their number may vary from the figure to figure.
The cube has 6 faces,
Okay.
12 edges, and 8 vertices.
So now you know what are edges, what are vertices. You must have learned about nets also, not required now.
A triangular pyramid has 4 faces, 6 edges, and 4 vertices.
Could you see it now properly here? The faces, the vertices, the edges.
There exists a relationship between the number of faces, vertices, and edges of a polyhedron.
Now for all the polyhedrons, we have a relationship that is F is the number of faces, V is the number of vertices, and E is the number of edges. When we combine them, they form a particular formula, and it is called as Euler's formula. That also we need to verify through the number of. Now see, for the polyhedrons, the number of faces, number of vertices, and number of edges may vary from polyhedron to polyhedron, and but still they all will verify this formula, or this formula holds true for all these polyhedrons.
This relation is called Euler's relation.
Okay, so this is Euler's relation or Euler's formula. verify Euler's relation for a particular type of solid shape. They may say for a cube or a cuboid, all these things they may say.
Here F stands for number of faces, V for number of vertices, and E for the number of edges.
And see, they have verified all this. Okay. So cuboid, triangular pyramid, triangular prism, pyramid with square base, prism with square base. For this, the number of faces, number of vertices, number of edges, this you have to learn, and then accordingly you will do what? F plus V equal to E plus 2. That's how. So if you get a question like that in your exercise, also questions will be given like exercise 17.2. They will say what? That verify the Euler's formula. The table is given. Complete the table. So that also you can see.
For a solid shape to be called a polyhedron,
Now this is a cone. Okay, this is also a solid shape.
all the faces must be polygons. If any one face is not a polygon, the solid shape cannot be called a polyhedron.
So if I talk, they are saying that there is a basic criteria for a polygon to be called as a polyhedron. So all the faces should be polygons only.
For example, if we consider a cone, the curved surface is not a polygon. Hence, this is not a polyhedron.
So this cone is not a polyhedron.
Similarly, a sphere cannot be considered as a polyhedron.
So sphere also is not a polyhedron. Why? Because each face of it cannot be said to be a plane figure. So polygon.
Since its surface is not made up of polygons, polyhedrons may be categorized as regular and non-regular polyhedrons.
So there are classifications given
For
for
the
them.
regular polyhedron, all the faces are regular polygons and congruent. Each vertex is formed by the same number of faces. For example,
So regular polygons we had done also the other day. Regular means the sides are equal, all the sides and all the angles are equal. That was in 2D shapes, but here it is now. It is in 3D also. Regular polyhedrons.
if we take the vertex shown, it is formed by the edges of four faces. If we take the top vertex, it is formed by four faces. Now, let's take a non-regular polyhedron. For this polyhedron, the top vertex is formed by four faces. In comparison, each of the bottom vertices is formed by three faces.
Clear to all? So this is non-regular polyhedron.
Next, we discuss about convex and non-convex polyhedrons. A polyhedron made up of convex polygons is called a convex polyhedron.
So see, if it is made
A
up of
polyhedron
convex,
containing at least one concave polygon.
so if that is polyhedron made up of at least one concave polygon, it's called as non-convex, and then second is convex. See, convex and non-convex, these are also part in our syllabus only. It is there. Convex polyhedrons, regular polyhedrons. Then what next?
Is a non-convex polyhedron. Let's see examples of convex and non-convex polyhedrons. Let's take the case of a convex polyhedron. If we check the diagonals of each face, every diagonal lies inside the polygon. Now, let's take the concave polygon. Let's take one of the polygonal faces. For the top face, the diagonal drawn from one vertex to the other vertex lies outside the polygon.
So see, we have done about convex and concave polygons also we have done. See, diagonal is lying outside. So it is
All prisms and pyramids belong to the family of polyhedrons.
can be different types of prism are also there and pyramids also. But they all belong to what? The face of the
A prism
polyhedron only.
is a polyhedron with congruent polygons as top and base and lateral faces that are made up of parallelograms.
Okay. So two triangular and three rectangular faces a prism is made up of. You must have done in physics also.
Examples of some prisms are shown here.
See? These are all types of prism, but they all come into the category of polyhedrons only. So it is there in the book also. A polyhedron whose base and top are congruent polygons and whose lateral faces are parallelograms in shape. This is called as a prism.
These prisms, top and base, are made up of congruent polygons, and their lateral faces are rectangles. A pyramid is a polyhedron.
So one category was prisms. Now next is pyramid. Let's see what a pyramid is. So see children, a pyramid is what? A polyhedron whose base is a polygon of any number of sides and whose lateral faces are triangles with a common vertex. So you take them together and join at the top.
Made up of a polygonal base and triangular lateral faces. Shown here are some pyramids. Observe that all the lateral surfaces are triangles.
So triangular, rectangular, square, pentagonal, hexagonal. Depending on what type of base is there, different types of pyramids are
In
classified.
this module, you learned that
All things you have done in this.
a polyhedron is a solid shape made up of polygonal surfaces. The flat surface of a polyhedron is called a face. The intersection of two faces is called an edge. The meeting point of three or more edges
These all
is
definitions are
called
also
a vertex.
important.
Euler's relation states that the number of edges subtracted from the sum of the number of faces and vertices is equal to 2. Regular polyhedrons have congruent and regular polygons as faces.
So these all things are there. These all
A
points are.
convex polyhedron is made up of convex polygons. A prism is a polyhedron with congruent polygons as top and base, whereas the lateral faces are made up of parallelograms.
So children, though you might not get direct definitions in the questions, but you may get these in the blanks in the exercise also. So the definitions of all these things you must learn and write also. In your copy you can write. And also you can make the table of the different types of shapes. It is given on the page number. It is given on the page. They have made a table out of it on page number 284. The number of faces, vertices and edges, and f plus p and e plus 2. So f plus p and e plus 2 can automatically judge. You just need to learn the number of faces, vertices and edges. If you can see in your book here, this way. So this is the page where page 284. This the table is drawn. Draw this table. You can also write the definitions of different types of pyramids and polygons. The polyhedrons, example, the definition of convex polyhedron, regular polyhedron, the prism, the types of prism, pyramid, and so for pyramid, what is given there? For pyramids, if the whatever type of base is there, if the base is triangular, we call as triangular pyramid. If the base is rectangular, we call it as rectangular pyramid. If the base is square, we call it as square pyramid.